many calculations that we're going to do in chemistry involve converting quantities from one unit to another. And when we do these conversions, we need to be very careful that we write these in numerator-denominator form. It's going to allow us to keep everything organized, and we'll take our given unit and be able to convert that to a new unit. So when we perform dimensional analysis, we will be given some type of unit. So we have a given unit. We will multiply that by some sort of conversion factor, which will be the given unit in the denominator and the new unit up in the numerator. When we multiply these together, we can cancel out the given units and end up with a new unit. And essentially what we're doing in this conversion factor right here is we're just multiplying by 1. Because oftentimes, for example, if we were multiplying, if our given unit was in feet and we had to convert it to yards, our given unit is feet, new unit yard. 3 feet are going to equal 1 yard. So these quantities right here, our given unit and our new unit, are always going to be equal, and that's what we're going to refer to as our conversion factors. So let's do an example of this dimensional analysis, and let's just start with 5.00 kilometers, and we want to convert this over to inches. So we start with the given unit, which is the 5.00 kilometers, and we need to convert over to inches. Oftentimes when we're performing dimensional analysis, it's not happening in just one step. So we kind of have to have a plan in our mind of how we're going to get to kilometers to inches. So first we need to convert kilometers to meters, meters to centimeters, then centimeters to inches. So our given unit is kilometers. We know that 1 kilometer is 1,000 meters. So again, like I said, we're multiplying by 1 by using this conversion factor. We're going to do that again and convert our meters to centimeters. And we know that 1 meter is 100 centimeters. And then we can convert the centimeters to inches. There are 2.54 centimeters in 1 inch. And in each time we're taking this given unit, which in the first case is kilometers, converting to the new unit. The new unit is now meters. We need to go to inches. So we convert meters to centimeters, and then centimeters to inches. This gives us 196,850.3937 inches. Now remember, we have to take into account the same significant figures when we do this conversion. So our given unit has 3 significant figures, and in each of these calculations, in our conversion factors right here, these are going to be exact numbers. So they're not going to limit the number of significant figures that we're going to do when we perform this calculation. So here we have multiplication and division, and that's what we're going to have for most of our dimensional analysis. So they're limited by the least number of significant figures in the least significant number. In this case, that's going to be 3. So we need to take this large number right here and convert the 3 significant figures. To do that, it would be best to use scientific notation, which would be 1.97 times 10 to the 1, 2, 3, 4, 5 to the 5th power. So 5.00 kilometers is going to be 1.97 times 10 to the 5th inches. Now let's try one more example here for dimensional analysis, and we are going to convert 1 meter squared to feet squared. So here we're looking at an area, and actually we're going to say this is going to be 1.00 meters squared over to feet squared. So here we have the square meter, which is a form of area. So if we start with 1.00 meters squared, I'm going to write this out a little bit longhand at first here and say it's going to be meters times meters, which would be our meters squared. So that's our given unit, and we need to go from meters squared to feet squared. When we do this, we're going to have to go from meters squared to centimeters squared to inches squared, and then inches squared to feet squared. So our given unit is 1.00 meters squared. We know that 1 meter times 1 meter is going to be equal to 100 centimeters times 100 centimeters. Note that this unit, meters squared, has 2 of these ones right here. So when we convert over to the new unit, we have to have 2 of those centimeters to cancel those out. I think it's easier at first, until you start to get used to this, to write it out in full notation here. Now we have to convert centimeters over to inches. Here we have centimeters squared, which needs to be converted to inches squared. So this will be 2.54 centimeters times 2.54 centimeters over 1 inch times 1 inch. Notice the difference from the previous example. In the previous example, we were converting centimeters to inches. Here we're converting centimeters squared to inches squared, so our conversion is going to be a little bit different. Now we need to convert those inches squared to feet squared, and we know that 12 inches are in 1 foot. So we can finish out this conversion right here. We have 3 significant figures in our initial unit. When we go through and do this calculation, that's going to be 10.8 feet times feet, or how we typically express this, it would be 10.8 feet squared. So these are 2 examples of how we would use dimensional analysis to go from a unit that we have given to some other type of unit that we need to calculate. We will be doing tons of calculations like this throughout the quarter, so make sure that when you look at these dimensional analysis problems, you know what you're doing, as this is going to be the core foundation for every calculation that we're going to use throughout the course.